Welcome FJA students to another edition of FJA Math Notebooks entries. Today we're going to be doing an entry on scientific notation. So you're going to need this sheet, you're going to need this sheet, maybe a little upside down for you, that sheet, your notebook, pencil, glue, scissors, maybe some color to add a little bit in at your own discretion. First thing, as always, let's cut around just the dotted lines here, and then we're going to title our notebook up here, Scientific Notation. All right, so title your notebook Scientific Notation, and then under it write, I can convert numbers from scientific notation to standard notation and back. And remember, we use scientific notation to express really large numbers and to also express really small numbers. And so that's why we're learning this, how to express really large numbers and really small numbers. Go ahead and do this. And then once you're done, we're going to glue on this piece of paper right here. So we're going to glue on this side. But before you do it, it might be helpful to fold along this black line, that solid line right there. So let's just do that. Fold along that there. That should be your fold. Glue on this side. And like this, so it opens like a book from the right. Now with this piece of paper out, I'm going to glue down on the back of this space. At first I did some folding along these two black lines. That can be important. And then I'm just going to glue the back here, the white space, so it is on the back of this. It should match up pretty perfectly. All right, so my pieces of paper are glued back to back. Now we can kind of open this here and we can start to write down some notes for ourselves. So first, standard notation to scientific notation. All right, if we have a positive exponent, we are going to move the decimal to the right. If we have a negative exponent, move the decimal to the left. All right, so we're going from standard notation to scientific notation. All right, so here's an example. Example number 1, we've got 1.35 times 10 to the negative fourth. And what this means is that we're going to write down 1.35, and we're going to move the decimal to the left. We're going to move the decimal to the left here 4 spaces. Since it's a negative exponent, move the decimal to the left 4 spaces. 1, 2, 3, 4. Let's fill in each of these spaces with a 0. 0, 0, 0. So our final number should be 0.000135. So do you see how scientific notation, writing this, can be a little bit more clear than having to write down this larger number? And that's why scientific notation can be really nice for representing really large and really small numbers. Example number 2. To write negative 5.8 times 10 to the 6th power, well, the exponent is positive, so we're going to move the decimal to the right. So first things first, let's write down negative 5.8, and then we're going to move the decimal to the right 6 places. Well, let's put some zeros in behind here so we have some things to move our decimal around. I'm going to put in 6 zeros, and let's see what happens. So we're moving the decimal to the right 1, 2, 3, 4, 5, and 6 places. And so our final number here is negative 5800000.0. So I think that's right. 1, 2, 3, 4, 5 zeros before the decimal. So that's really, if we put commas in there, that's negative 5,800,000. Perfect. All right. So going the other way, when we're going from scientific notation to standard notation, so we move decimal to make the number in the ones place. And actually, I realize I'm kind of explaining this backwards. This is to go from standard notation to scientific. This is scientific to standard. Okay, so this is standard notation. Scientific has the 10 with the exponent. So in order to go from standard notation to scientific notation, we're going to move our decimal to make the number in the ones place greater than or equal to 1, but less than 10. So we want to move the decimal to make the number in the ones place greater than or equal to 1, but less than 10. So let's look here. Well, the decimal's here, so the number before it is definitely less than 1, right? So it's got to be greater than 1 because we got 0 here, so that's less than 1. So we're just going to keep moving back. If we put the decimal here, nah, it's still 0 to the left. Here, 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 here. Excellent. So if we tried to put it right here where that comma is, the number before it is actually greater than 10. It's 26. We still got 26. So let's move it one more time. And so this is where we're going to want our decimal. And what we did is we moved our decimal back 1, 2, 3, 4, 5, 6, 7 places. And then to write this in scientific notation, we're going to write 2.64. 2.64, and this is going to be multiplied by 10, and then the exponent here should tell us where do we need to move this decimal in 2.64 to represent this number. Well, we need to move it to the right 7 places, so it's going to be 10 to the positive 7th, because remember, when we have a positive exponent, we move that decimal to the right. So these two numbers are equivalent, 2.64 times 10 to the 7th, and 26,400,000, same numbers. Same thing with this one. We're going to move our decimal to where the number to the left of it is greater than 1, but less than 10, greater than or equal to 1. So it's going to have to end up here. So we could write, let's write, technically there's a 0 there, and that's totally fine. So we've got 2.0 times 10, and now we have to ask ourselves, okay, where do we need this decimal to move to in order to represent this, the original number? Well, if we have 2.0, I'm going to need that decimal. If it was here, I'd need it to go back 1, 2, 3, 4, 5, 6 places to the left. So it's going to be 10 to the negative 6th power. I hope that helped you all conceptualize a little bit better how we can move back and forth in scientific notation and standard form.